Hi. Today I'm going to talk about a particular case study with SDVoE related to operating room integration. Operating room integration in itself has more than just AV, but today's topic will mostly be around audio video routing, and I'll briefly touch base upon some of the added advantages with the auxiliary channel of SDVoE. My name is John Thomas, and I'm from Jam Labs. I'm a CEO and CTO of Jam Labs. We are based in California, in Fremont, and we do primarily operating room integration based products. So, for those of you who are not familiar with operating room integration, it's sort of what's shown in the picture here, and it's the implementation that Jam Labs does is far beyond just the OR, but it's also outside the OR. So think of audio video routing as a orchestra that happens in the OR, where there's a person called a circulating nurse, and her job, one of her jobs, is to route different type of sources to different type of destination points. And right now I'm showing you typically a boom mounted operating room. It's an integrated operating room, so there's very little cable on the floor. Everything is managed either through the booms or through the walls. So the large displays are primarily used for multiple images, so like multi-view options, where you can show a patient life monitoring system. You could have PACS images being pulled up. So they're all medical grade displays, not the usual AV displays. That's one of the difference between ORI and a professional pro AV application. So everything that's draped in blue there is supposed to be sterile. So any display that's over a patient cannot be vented or does not need to have fans, because the moment you have those, then you end up contaminating the sterile field. Now, typical ORs are built about, anywhere from $500,000 to maybe $700,000 each OR with all the equipment inside. Now, the current global operating room integration market is about $2.5 billion. And with a forecast projection of 10.5% year-over-year growth, it's predicted to be about $4.8 billion market globally. Okay, so it's a fair bit of growth there. So a typical OR, like I said, is an orchestra, and if you can think of a fair set of clinical expertise that comes together and coordinates a surgery from happening. Doctors or surgeons are generally clients or customers to the OR. So what they recommend is they bring in the patients, and efficiency is of utmost importance, because an OR, for lack of a better term, you can view it as a production line. So in an entire hospital, OR is the only segment that actually makes money. Rest everything is losing money, right? So it's utmost important to maintain that workflow, maintain that efficiency and speed. So that's where I think sort of SDVoE comes in as one piece, where you're bringing in a sterile area, right? So there's no fans on them. You cannot use FPGAs-based designs in an OR, primarily because it contaminates the sterile field. And as FPGA-based designs will use a fan, and fans have mechanical components which are the first failure in an OR. So imagine an OR goes down for half an hour, okay? That's hundreds of thousands of dollars lost, okay? So the primary functions are capture, store, share, and access, okay? And it's all centered around a patient. So being vendor neutral is important. A nurse or a clinician is not necessarily a tech expert, right? I mean, like, everybody understands what's a DisplayPort and an HDMI cable difference. But if you give it to a nurse who is running around with 50 other jobs, right, trying to plug in that cable into the wall will create confusion, create damage in the long run, potentially even bring down an OR. So think of SDVoE as a boon, because it is potentially offering a vendor-neutral solution. You do not want a nurse confusing, okay, is this a DVI or a DisplayPort cable? Rather, you build a universal cable which plugs into your SDVoE module, brings out that video, and can transition from, let's say, 1080p to 4K to 8K and seamlessly without her having to decide which port does it go into. So JamLabs has been able to produce a universal cable that makes this kind of transition easier. And being vendor neutral and getting away from a proprietary solution is important because in an OR, not every product is built by one company. Okay, so imagine if you have your home theater where you go purchase a DVD player and you plug it into a TV, and if it does not work, either the TV is going back or the DVD player is going back. Whereas in an OR, you do not want that sort of confusion. You build a vendor neutral platform where you have 200 plus or 100 plus companies in the SDVoE forum that are designing products for various Pro AV kind of implementations, right? So you can technically bring one product from one vendor and make it work with another vendor. So that's very important to be vendor neutral and agnostic to that. Ease of install, again, being boom mounted or wall plate designs are possible with SDVoE Semtech chipsets because they're not using FPGAs, right? And so it's heat management is much better. So they can go into like a pendant wall or a boom, makes it clean, makes it, again, sterile, right? And future-proof and scalability is important. Again, nobody designs a chip for an OR application or a medical application. Guess what? The volumes are low. Okay. On the good side, the margins are higher. The disadvantages, many of the consumer electronics and Pro AV market or broadcast market, chips get designed for that market. And then you kind of get some of that flowing into the medical segment, right? SDVoE is sort of that bridging gap for us, right? Being able to take something from the Pro AV or broadcast market and bring it into the medical space. And again, people, like I say always, people don't buy products, people buy solutions. So to be able to present a complete solution with that whole vendor neutral platform makes it easier because you have other companies participating in that ecosystem, right? So I could buy a Pro AV based product, like a sound extender, like, that's something that works on Dante, that goes on the SDVoE pipe as an auxiliary data, gets to the other side, I can decode it, right? Again, cyber secure and IT friendly is another piece of the medical market, and being AES encrypted, this data is protected. Obviously, you do not want HIPAA violations in medical. Cost competitive, again, FPGAs have been notorious, and as pressure increases on the supply chain, that's going to get worse and worse, right? Having a steady state ecosystem where ASICs are coming out potentially solves that problem. Okay. So again, key touch points for an operating room, an ideal solution is being able to truly 4K scalable. One example is a pathologist today sits in another location, and the doctor is conducting a surgery. He's cutting out a portion of the tissue that's cancerous. Now, he puts that tissue under a microscope. The microscope takes that image and feeds it out into the pathologist lab, who is making a decision to cut more or cut less, right? So imagine in the past that same exercise was done where a tissue sample was taken and the nurse would run over to the pathologist in the other building, put it under a microscope. At that time, the patient's open on the table. So that example it's an example of how having video over the network solves that problem, and potentially uncompressed video over the network, right? And everybody, as I walk through this Pro AV space, I'm saying everybody talks about audio, video, music in its or lighting in its unique column. But in an OR, think of it as a workflow, okay? And this might apply even to Pro AV space. When a patient's wheeled in, if the patient's a certain age, we can pull up that data from the patient's EMR or the hospital EMR. You can trigger, for example, the room lights, the displays to play like some sort of a cartoon. So the patient, or it's a kid who is being wheeled in, feels calm, right? And it can maintain that environment, right? So those are kind of the sort of the byproducts of having video over IP and being able to take that auxiliary data and apply it to real life examples, right? So adapting to OR workflow. So we are in the, from a company point of view, our value add is taking something from the Pro AV broadcast space and implementing it into real life examples and solving that problem using software. Centralized monitoring, predictive analytics, remote diagnostics. I think the previous gentleman who was presenting also talked about that. SDVoE allows you all that. It's fairly easy to do. You know, everything is on the network. Fantastic solution, right? You can predict when a cable goes loose rather than when a cable is really broken and a patient gets wheeled in and then you realize, wait a minute, I cannot use this OR, right? So imagine that advantage. A small form factor, you saw in the OR, the last thing you want is have a IT rack filled with all equipment. Nobody wants that. Clinicians, the center, the focus is on the patient and should be on the patient, right? So that's kind of better. I think, and again, having an open API for interoperability. I can take the API from Semtech or SDVoE and I can build my own set of functionality on top. So my value add is in trying to solve a problem, not reinventing the wheel of how to push video over IP. This is, our design. Obviously, the skin is completely customizable. Seamless switching, important, because when a nurse tries to route one image to a display, if it takes 3 seconds, imagine the surgeon who has an endoscope stuck in somebody's body, waiting for that image to come up. Right? So seamless switching is very important. And having a preset management is important because if it's, let's say, Dr. Peter who walks in, Dr. Peter has a special preference of where he's going to stand. Depending on the modality of the case, he wants the case and the image routed to different displays. Okay? So that's some of the things that you can do. And obviously, a lot of it has to do with software, but given the flexibility with the SDVoE solution, helps us to generate better solutions in the end. Ultra low latency. I'll give you an example. A kid who plays video games, and you can see there was an implementation of a 3D video game, and it's great, but play it for 15 minutes, and then you start introducing fatigue in yourself, right? That's because the hand-to-eye coordination is lag. There's a lag. Okay, so a surgeon who is operating on a patient, if the hand-to-eye coordination is lagging, anything more than 2 frames, he will, hands down, find out that he is fatigued after a couple of hours. Now, some of the surgeries go on for like multiple hours. Some go in as long as 12 hours for a neuro surgery, right? So, or a cranium surgery. So, it's important for the surgeon to see a 0 lag latency video. That's the benefit of having something that is non-compressed, doesn't take too much of processing. And the Semtech chipset actually does a line-based encoding, which prevents it from, having too much lag in the design. As it is, the displays will introduce lag, right? So that's one application. And being able to detect which sources. So if you have 500 sources, okay, for the nurse to find it, when the surgeon is going to say, hey, route that C-arm to this display, he's not going to say source number 8 or so. So it's important to only bring in those icons that are important during a surgery. So we can auto-detect it from Semtech, detect whether there's an active video, active link, and bring up those icons that are relevant and those icons that have active video on them. So color coordination, right? So we can do recording, we can do privacy. There's a lot more functions that we can go into. And like I said, building something like a wall plate design which has no fans in them. Ability for surgeon to pull up a PACS image or a charting computer without having to break scrub. Okay, so JamLabs is a solution that's based on SDVoE, but also adds an additional technology where a surgeon can control a PACS image right from the sterile field, right? So he doesn't have to go touch. Imagine if he has to refer to an image, he has to break scrub, go refer to the image, come back scrubbed in, all the while the patient's open. So you not only reduce or increase the safety, but also reduce the time. So which means the OR is more efficient. And that translates to money. Because if a patient gets readmitted for a case, then the hospital does not get paid from the insurance. So, there's a financial motive to solving this. So like I said, having a universal cable, like the one that you see below, it removes the guesswork. You take a DVI cable, you plug in 6 times into a wall plate, the 7th time, that pin is bent or something else gone wrong, right? And right at the time of the surgery, if it doesn't work, you're in trouble. So having a universal cable solves that problem, right? We can pull up, like I said, a work list. We can make customizable surgical checklist. All of this is routable. Checklist is another important point. Many cases in the US, once the surgery is done, they make a mistake of whether it was the left side or the right side, right? So when you go into a surgery, many patients actually take a permanent marker and mark it, saying this is where you want to operate. Because remember, it's a production line. So there's 50 surgeries happening in a room. You don't want to be that statistics, right? So ability for me being able to customize a surgical checklist, what I'll do is I'll pull up the information from the hospital computer. So I can easily pull up the checklist, even if the computer is far away in an IT closet, as a feed into the room. Having an encoder right at the IT closet, I can pull that information back. And having KVM gives the surgeon the ability to control it. Fanless box, hands down. I'm not going to design anything that is a fan in the surgery room. Right? That's our display. It has SDVoE built in. You do not want another box in the back of the display hanging right over the surgeon or right over the patient, because cable management becomes a problem. Having integrated, and we build our own scalers and displays, the entire thing is designed using SDVoE. Again, centralized dashboard, being able to control diagnostics, being able to do predictive analytics, being able to remotely monitor. Again, possible with SDVoE. Some of our products, and like I said, we are not the only company that makes a product. This is not a product pitch from our company. It's a example of how you can leverage from 100+ companies in the SDVoE ecosystem. Okay. I think that sort of concludes my presentation.